Okay, so we're going to unpack one of the biggest, most fascinating arguments in computing history. It's this 30-year-old debate that, and you might not even realize this, is quietly shaping pretty much every single device you use today.
And I'm not exaggerating. This wasn't some quiet academic chat. Nope. This was a full-blown flame war on a public message board, no less, between two absolute giants in the field. And believe me, the way this story ends, nobody saw it coming.
So, to really get what this fight was all about, we've got to introduce this star of the show, the kernel. So, what is a kernel? Well, you can think of it as the heart, the absolute core of an operating system. It's kind of like the boss, the translator, and the traffic cop all rolled into one. It manages your computer's memory, makes sure when you click your mouse something actually happens. You get the idea. It's that crucial bridge between the apps you use and the physical hardware of your device.
All right, so back in the late 80s, early 90s, there were two totally different schools of thought on how you should actually build one of these things. Two competing philosophies, and they were really at odds.
In one corner, you've got the monolithic kernel. Think of it as all-in-one. It's integrated and it's built for one thing: speed. And in the other corner, you have the microkernel. Its whole deal is being modular, separated, and built for rock-solid stability. And trust me, these simple words, they hide a massive, really important debate about how to build software.
Okay, so what does that really mean? Well, a monolithic kernel, just like the name suggests, is one giant piece of code. Everything, your device drivers, file systems, the whole shebang, it all runs together in this one protected, privileged space. A microkernel, it's the total opposite. It's super tiny. It does only the absolute essentials. Everything else, like a driver, runs as its own separate program in a less important area. It's a completely different way of thinking.
And this one choice, monolithic versus micro, is what lit the fuse on one of the most legendary public arguments in the history of tech.
So, let's set the stage. It's 1987. A professor, Andrew Tannenbaum, creates this OS called Minix. It's based on a microkernel, and he made it mainly for teaching. Fast forward a bit to 1991, a student in Finland, you might have heard of him, Linus Torvalds, gets inspired by Minix and decides to build his own kernel. But he goes the other way. He makes it monolithic, and he calls it Linux. Then in 1992, things get interesting. Tannenbaum goes onto a public message board and just drops a bomb.
Can you just imagine logging on and seeing that? Linux is obsolete. Wow. The guy who literally wrote the book on operating systems publicly calls this new kid's project a dinosaur before it even gets started. That, right there, was the first shot fired in the kernel wars. So Tannenbaum's whole point of view was very academic, very big picture. He was basically saying, look, monolithic kernels are ancient history. That's 1970s thinking. The future, he was absolutely sure, was the microkernel. It was just a better, cleaner, more correct design. And he really went after Linux for being tied to one specific chip, the Intel 386. He saw that as a huge mistake, basically a dead end. And Linus's reply? It was classic Linus, super pragmatic, and yeah, pretty blunt. He was basically like, hey, your thing isn't perfect either, and I'm just making a free OS for fun on hardware that people actually have. I'm not asking for money. If you don't like it, don't use it. Talk about a mic drop.
And this exchange just perfectly sums up the whole conflict, doesn't it? You've got Tannenbaum, the professor, focused on the theoretically pure, correct design for the future. And then you've got Torvalds, the hacker, just focused on making something that works and works well, right here, right now. It was the ultimate clash of theory versus practice.
But this wasn't just about two guys arguing online. What their debate really brought to light was this huge, fundamental trade-off that sits at the very heart of how you design an operating system. Okay, so let's break down the pros and cons here. With a microkernel, the big ones are size, security, and flexibility. It's smaller, it's easier to add stuff to, and, this is a big one, if one part, like a bad driver, crashes, the rest of the system keeps on chugging. The catch? It's slower. All those little pieces have to talk to each other, and that takes time. Now, the monolithic kernel is the exact opposite. Its big advantage is speed. Everything's in one place, so communication is super fast. But the risk? If one little piece of code has a bug, boom, the whole system can crash. So that's the core conflict, right there. It all comes down to a choice. What do you care about more? Do you want blazing speed, or do you want bulletproof security and stability? For years and years, that was the question.
But you know how it is with tech. The answer is rarely just black or white. It's not always one or the other. And sure enough, a new approach started to pop up, a compromise that tried to grab the best parts of both. And that brings us to the hybrid kernel. The name kind of gives it away, right? The whole goal is to get the best of both worlds. It isn't a pure microkernel, but it's way more modular than a monolithic one. It lets you have some of that flexibility, loading and unloading pieces as you need them, without going all in on separating everything.
And you might be wondering, where do you find these hybrid kernels? Well, pretty much everywhere you look. Your Windows PC? That's a hybrid kernel. Your Mac? Your iPhone? Hybrid kernel. These massive operating systems found a happy medium, a way to balance that constant push and pull between performance and stability. So looking at all this, it really seems like the pure microkernel idea kinda lost, right? I mean, Linux, the monolithic kernel, totally took over the server world in Android. Then you have Windows and Apple, they went with the hybrid approach. It really looks like Tannenbaum's vision of a pure microkernel future just didn't happen. But you're not going to believe the twist at the end of this story.
Yeah, for years and years, it looked like Linus's super practical approach was the undisputed champion. You saw monolithic and hybrid kernels just everywhere. It looked like case closed. But the story wasn't finished, not by a long shot.
3 billion plus? What if I told you that the most widely used operating system in the world isn't Linux? It's not Windows, it's something else. Something running on literally billions of devices, hidden right under our noses.
Okay, here's the twist. In 2017, it came out that deep inside almost every Intel chip made since about 2008, there's this tiny separate computer called the Intel Management Engine. And guess what OS it runs? Minix, Andrew Tannenbaum's microkernel. That tiny, super secure, super stable OS he championed was the perfect choice to run on the most secret, most powerful part of the chip. Which means, yeah, Minix is arguably the most common operating system in the world.
So what's the big takeaway here? It's that neither side really won or lost. The truth is, we needed both. We absolutely needed the raw performance of monolithic designs like Linux to build the servers, the smartphones, the whole digital world we live in. But at the same time, we also needed the incredible security and stability of a microkernel like Minix for those supercritical jobs, running deep down in the hardware where things just cannot be allowed to fail.
And that leaves us with a really interesting question, doesn't it? As we look to the future, with our tech getting more and more complex and things like security becoming more important than ever, which philosophy is going to win out? Are we going to stick with monolithic speed, or will the future be all about microkernel security? It seems like this 30-year-old debate is still just getting started.